Okay, let's go to page 60, and this is section 5.3, and this is about hyperbolas. Okay, so hyperbola would be, it's like almost like two parabolas, okay? And the equation, the standard form for hyperbola would be x minus, it's very similar to the ellipse. So you're going to get x minus h squared over a squared minus y minus k squared over b squared equal to 1, okay? And so I'm going to put a form first, and also you can have the y minus k squared over a squared. Notice that a squared always comes first, okay? But for hyperbola, the c is the biggest number, so you have the a squared plus b squared equal to c squared, okay? So ellipse is kind of, the a squared is the biggest number, but for here the c is the biggest number. Okay, so the first variable give you the direction is second opening. So x comes first, so it will be open in the x direction. This one, the y comes first, so it will be open in the y direction, so it will be like this. Okay, so they give you the direction. And the h and k will give you the center. A and the b will give you the box. Okay, and also you have the, so when you're doing the graph, if you look on page 60, okay, they kind of give you this picture like this over here. So whenever you're going to sketch, so this point over here is your center. Okay, so again, this is your, so this in the x direction, so this would be this equation over here. Okay, and so this would be, since this is under the x, so this would be in A would be in the x direction, so this would be the A over here, okay? And B is under the y, so the y direction would be the B, A, and this would be the C. Okay, so this is your triangle ABC, okay? And here's your center, and this is the vertex right over here. So that's the vertex right over here, and that bit in, okay? This would be the focus, okay? And this distance over here, that's your C. So again, if you were to draw a circle, if you use this as your center and use the C as your radius, when you draw a circle, notice that the F would be on the diameter. Okay? So it's kind of pretty cool how everything all kind of fit in together. Okay. Okay, and also there are a couple names over here. So again, this is the center, this is the vertex. Vertex would be touching the box, and this is the focus. And this axis right over here, this is called a transverse axis. Okay? And this right over here, this is called a conjugate. Axis. Okay. So those are kind of parts of the hyperbola. Let's see, what else do we need to know? Okay. Okay, the dashed line over here, this is called the asymptotes. Okay, so the dashed lines are asymptotes. And so those are just kind of the definitions and parts. Okay, so now let's go with some example to see how everything all fit together. Okay, so let's go to page 61. Let's look at example 5-9. Example 5-9, it says find the asymptote, vertices, center, foci, and the length of the axis. Okay, so length of the axis of, so you have this equation, 9x squared minus 4y squared plus 18x plus 16y minus 43 equal to 0. Just like ellipse, you need to go ahead and complete a square. Okay, okay, this is the y. Okay, so let's go and plus 43 on both sides first. And you need to start to group your x together, group your y together. And notice, now this is subtraction, right? So you have to be careful. You want to put the positive in front. So if you have like a y squared is positive, x squared is negative, then you have to put y squared in the front, okay? Because you have to have a positive then minus something, okay? Because your standard form, see the minus, okay? So whatever is negative, you have to put in the second position. Okay, so over here, so go and group them together. So you got 9x squared plus 18x. Again, just like ellipse, leave a space. And you always put a plus between the group, okay? So you got negative 4y squared plus 16y equal to 43. Again, notice I put plus over here. Always put a plus between the group, because if you put a negative over here, you're going to mess up on the sign, okay? Okay, next, let's go and factor the coefficient. So factor the 9, you get x squared plus 2x. This one, there's a negative, so you have to factor the negative 4, okay? And that's when you have the negative. So it becomes y squared minus 4y equal to 43. And double check very quick. Negative 4 times I give you that. Negative 4 times negative 4 give you positive 16. Okay, next, you can go and get your template for the perfect square. Okay, so get your template ready. So now, this one you need to get plus 1. So you need to plus 1 right over here. Right? So this you get that. And there's a 9 in the front, so 9 times 1 will give you 9. So you need to plus 9 to even it out. Okay? Over here, you need to get minus 2. Right? So minus 2 squared give you plus 4. And there's a negative 4 in front. So when you multiply, you're going to get minus 16. Okay? Okay. So once you do that, you go ahead and subtract. You're going to get 36. Okay? And then you have to make this equal to 1. So divide by 36. Divide by 36 on each term. Okay, so you're going to, so this cancels, so you get x plus 1 squared over 4 minus y minus 2 squared over 9 equal to 1. Okay, so from here, we can start to answer the question. Okay, so center is going to be at negative 1, comma 2. Okay, now to answer the other questions, we're going to sketch it out. So center is negative 1, positive 2. And just like ellipse, everything is going to be based on that center. So here's your center. Okay, now notice there's a 4 under the x, right? So this is your a squared. So you take the square root. So a squared equal to 4, so a equal to 2. B squared equal to 9, so b equal to 3. So we have to go 2 in the x direction. So don't mix up the variable. Again, this is under the x, so you have to go in the x direction by 2. Okay, so from here you go 2 in the x direction. So you go 2 in the x direction. Okay. And so that's the face of your box. Again, from the center, you have to go 3 in the y direction. Okay, so you go 3 in the y direction. So that is your box. And you go down 3. You have to go up or down. So that's your rectangular box. Okay. Since the x comes first, so that is your vertex right over here. So that's your V. Okay. Okay. Now, once you get your box, then you go and draw the diagonal dash line. Those are your asymptotes. the asymptote would be your boundary for your graph. Okay? So your graph would be going like this. Okay? And notice the graph will touch the box at the point V. Okay, so that is your graph. So now let's go and answer all the questions now once we have all these. Okay, the center is at -1, 2. Okay? And so this is 2 and this is 3, right? And so what we need to, okay, we need to find the asymptote. So asymptote is very easy, okay? See what you have over here, that would be your basis for your, so basically what you do is to find the asymptote, you set this equal to 0, okay? And set this equal to single power. So you see this over here, so the asymptote for this, you just follow that, okay? So you're going to have y minus 2 equal to plus or minus, okay? So y minus 2 equal to plus or minus, and look at the slope. The slope of the asymptote would be 3 over 2. See the 3 over here, see the box? So it would be 3 over 2 times x plus 1. So that would be your asymptote. And the reason for plus or minus is because you have 1 here, 1 here. And that's your plus, that's your minus. Okay? Again, you just take the parentheses, and just use a 3 over 2 from here. Or you can just use the, you can get it from, easier to get it from the picture. Okay? So that's your asymptote. That's your equation for asymptotes. Okay? Again, it's very simple. Once you get that, you can simplify if you want to, or you can just leave it like that. Okay, so let's go back to the list. So asymptote, okay, got that. Vertex, okay, so we need to get a vertex. Okay, again, start from here. You start at -1, 2, and you go this way. That's your x. So you have to, so -1, you start at -1, you go 2, so it becomes +1, comma 2. Okay, and this one, you start at -1, you go 2 this way, so it becomes -3, comma 2. Again, when you go sideways, the y stay the same. See the 2, 2, 2, right? When you go sideways, y stay the same. Okay, so we got this, we got center. Okay, we need to get this over here. So the focus is a C. So, so C equal to 3. C, you have to use the Pythagorean theorem, right? Okay, so let's find C. So A squared plus B squared equal to C squared. So A squared is 4, B squared is 9, equal to C squared. So C squared equal to 13. So C equal to square root of 13. Okay, so you can start from here. So the F would be kind of right over here. So this is going to be the F right over here. Okay. Again, start from here and you go this way. You have to add onto here. So you start at -1 and you go square root of 13, so it would be plus square root of 13, comma 2. Okay, so that would be the focus. And when you go this way, you start at -1. You go this way, you have to subtract. So it would be minus square root of 13, comma 2. Okay? Okay, so that takes care of the F. And what else we need to know? The length of the axis. Okay. So this one is a transverse axis. So transverse axis will equal to 2 and 2 is 4. And conjugate axis would be this way, so would be 3 and 3 would be 6. Okay? And that's it for this one. Okay, let's go to the next example. So on page 62, and example 5-10, it says, what if we complete a square for hyperbola resulted in, like this one here, you got x minus 1 squared over 4 minus y plus 2 squared over 9 equal to 0. Now what happens when you end up with equal to 0 instead of equal to 1? Well, in this case, what will happen is when you have equal to 0, you're going to get something called degenerate hyperbola. Okay? And when you have this situation, basically when you have equal to 0, the equation reduces to two asymptotes. See the asymptote over here? Okay? So when equal to 0, that's equation for that. Okay? So in this case, your equation would be y plus 2, right, equal to plus or minus, you have to be careful, it has to be y over x, so it would be 3 over 2, right, 3 over 2 times x minus 1. Okay? And that's it. Again, notice in the book, they kind of put the x on this side, y on this side, right? And that's why it looks different, okay? But you're going to end up, again, when you equal to 0, you're going to end up with one pair of lines, the asymptotes, okay? This is when equal to 0, this is when equal to 1. Okay? And that's the situation. And the next one, right below the example, you have this, it says consider graph of the curve xy equal to 6. So this is actually also hyperbola. If you were to sketch it out, if you make the table, if x, obviously you cannot equal to 0, right? So if x equal to 1, y equal to 6, and negative 1 give you negative 6, 2, 3, negative 2, negative 3, and you can have a 3, 2, and negative 3, negative 2, and you can have 6, negative 1, positive 1, negative 6, negative 1. Okay, so again, if you make the table of the points and if you plot that, okay, I'm not going to plot, just anyway, you're going to plot the dots, you're going to end up with something like this. Okay, and again, it's a hyperbola, and this is a hyperbola with the xy term. Okay. Okay, so that's it for this one.